So in this area here is the actual test lab to the facility. This is where we do all the pre-radiation work before we actually do any of the radiation exposure. So all the measurements that are done here, all the parametric testing are actually supported in this area. The pre-radiation data we collect, we submit to the customer. When approved, then we go ahead and proceed with the actual radiation exposures and then go forward with the post measurements again in this area. So overall, this room here meets every single ESD standard, and also we comply with all of the requirements mandated by DLA. So over here, we have the testing system for the semiconductor devices. What this supports is the 3-pin discrete devices. Primarily, most of the FETs gets tested here that come in-house. VJTs, diodes, etc. are all supported here. This is a high voltage, high current system, so essentially we can really provide capabilities for a variety of part numbers that way, if not all.
My name is Leo Bobek. I'm a senior engineer for VPT Rad. One of the most important aspects of doing radiation testing on electronic devices is to be able to measure accurately the radiation exposure on the devices. And the method we use here is alanine dosimetry. These small alanine pellets are irradiated with the electronic devices, and by measuring the radiation exposure on these pellets, we have an accuracy that exceeds industry standards.
This is our radiation test area. This is where we have over here the gamma cell. The model is the GC220. Right now, the dose rate on that system is about 112 rads per second. So the components essentially get submerged down. We interface through it through a 1.5 or 1 1/4 inch conduit, and we can monitor the components in situ as the parts are being exposed. We can monitor the leakage currents, if there's any increase there over radiation, as well as we monitor all the feedbacks from the voltages as the parts are getting exposed. Okay, so this next area is low-dose radiation environment. It's the bunker which houses all of the TID work that's rendered for the 10 millirads, mostly done for elders analysis. Back here, this array takes care of 10 millirads or less, and in this area here is where we accommodate all the requirements from the European customers that we have. This range here covers anywhere from 10 to 100 millirads per second.
This is our scientific test model 5200 tester. We use it for gathering extremely precise data on our semiconductor devices, and it has allowed us to maintain a standard that our customers really desire. The system itself allows us to get picoamp measurements that are consistent and reliable day to day, week to week, across any long-term test we might perform.